Okay, welcome students to 5.2. Okay, verifying trigonometric identities. Hints to consider when verifying identities. Use the fundamental identities or their equivalent forms. Number 2, rewrite the more complicated side of the equation. Number 3, express all trig functions in terms of sine and cosine. That's very helpful. Number 4, perform any factoring or indicated operation. Number 5, keep the goal side not changing. And this is really just a suggestion. I'm not too concerned about the side not changing. In mind when selecting substitutions, if an expression contains 1 minus sine x, 1 plus sine x, 1 minus sine x, 1 plus cosine x, or 1 minus cosine x, multiply the numerator and denominator by the conjugate. So the conjugate is when you have, say, is just the same thing, but with the sign difference. Say you have 1 plus sine x, the conjugate to that is 1 minus sine x. So we call these conjugates. Okay, so we call them conjugate pairs. So it's basically the same terms, but the sign is flipped. So if it's a minus sign, it becomes a plus sign. Okay, and those are called conjugates. Okay, so let's verify the equation is an identity. That basically we're verifying that the left side is equal to the right side. So the cotangent squared times the tangent squared plus 1, does that equal cosecant squared? So what I'm going to do is I'm going to distribute the cotangent first. Okay, performing these operations. So cotangent squared x times tangent squared x plus cotangent squared x times 1, okay, is equal to cosecant squared x. Okay. So now cotangent squared x is going to be 1 over tangent squared x. I'm going to change that cotangent. And then this is tangent squared x plus cotangent squared x equals, does that equal cosecant squared x? Okay, basically what we're saying is there's like a question mark here. Are these going to be equal? And if I multiply 1 over tangent squared x times tangent squared, those cancel. And this becomes 1 plus cotangent squared x equals cosecant squared x. And there is an identity that says 1 plus cotangent squared x equals cosecant squared x. We saw that in the previous section here, right here, 1 plus cotangent squared theta is equal to cosecant squared theta. So we can use that directly, that fundamental identity. And we can use that down here and say, yes, cosecant squared x does equal cosecant squared x. And so that checks. Okay, so we know that the original one here checked. Okay, that does, those two do equal. Because we ended up with something equal to something else. Now for this one, we want to change things into cosines and sines. What I'd really like to do is I'd really like to simplify kind of both sides at once and see if I can get to something that they both equal to. This side over here, that guy I can FOIL out. And when I FOIL this out, I get the middle terms to cancel out. And so this becomes 1 minus cosine t plus cosine t minus cosine squared t. Okay. And so that's that side of the equation. On the other side of the equation, I'm going to change to sines and cosines. Okay. So this is going to be sine squared t over cosine squared t all over 1 over cosine squared t. Now what's nice here is that when I multiply both top and bottom by cosine squared, the denominators cancel out. So this just becomes sine squared t is equal to, now these cancel out, those middle terms cancel out on the other side, and I'm just left with 1 minus cosine squared t. And 1 minus cosine squared t, according to the Pythagorean identity, remember we had sine squared t plus cosine squared t is equal to 1. Well, if I subtract cosine squared t from both sides, I get sine squared t is equal to 1 minus cosine squared t. And so we get, yeah, we do get sine squared t is equal to sine squared t. Okay, and so it does check. Okay, and even though we didn't end up with what we started with, we did end up with something equal to something else. And so we can say that the original identity is true. Okay, so this identity checks. Check. Check. Okay, verify that the equation is an identity. Now for this one, we have a proportion. We have one fraction equal to another fraction. And so what I'm going to do is I'm going to cross multiply so I can do some algebra. Okay, I'm going to cross multiply these guys. And I'm going to say, okay, secant x plus tangent x times secant x minus tangent x, does that equal sine x times cosecant x? Okay. Okay, and then I would FOIL this out again, and I end up with what's called the difference of two squares. The middle terms will drop out again, and we're just going to get secant squared x minus tangent squared x. Squared x. And then over here, we're going to get sine x times 1 over sine x. And so those cancel out, they just become 1. Okay. And so I get secant squared x minus tangent squared x, does that equal 1? And so I'm going to add tangent squared x to both sides. And I get secant squared x, does that equal to 1 plus tangent squared x? And once again, this is a fundamental identity. Okay, this is secant squared x equals 1 plus tangent squared x. That is true, because again, when we go back to our fundamental identity, okay, secant squared x does equal 1 plus tangent squared x. Okay, so to make this equal, I would just say that 1 plus tangent squared x is equal to secant squared x. So secant squared x does equal secant squared x, and that checks. Okay. Okay, on the last one here, on example 7, what I'm going to do again is I'm going to cross multiply and see if I can get this to simplify, the right side and the left side to simplify into something that's equal. Okay, so let's cross multiply again, and we're going to say that the cotangent of alpha, that little a there is alpha, it's a Greek letter, stands for an angle, angle alpha, minus cosecant alpha times negative sine alpha, is that equal to cotangent alpha plus cosecant alpha times 1 minus 2 cosine alpha plus cosine squared alpha. Okay. So what I'm going to do is I'm going to distribute this all. Okay, so let's distribute. Okay. So I end up with cotangent alpha. I'm going to separate these guys. Okay, cotangent alpha times negative sine alpha, okay, minus cosecant alpha times negative sine alpha. Let me zoom in a little bit. Cosecant negative sine alpha. Okay, that equal, okay. Let's see, what do I want to do? Maybe I will multiply this out. Okay. I do know that this thing actually factors. This thing actually factors into 1 minus cosine alpha squared. So that's an interesting thing. Okay. Or 1 minus cosine alpha times 1 minus cosine alpha. Okay. And then I'll just keep this cotangent alpha plus cosecant alpha. Okay. On that side. Okay, so this cotangent alpha, I'm going to change everything to now sines and cosines to see what I'm dealing with. And so this becomes cosine alpha over sine alpha times negative sine alpha. So we're going to see that those sine alphas are going to cancel. Minus 1 over sine alpha, that's cosecant, times negative sine alpha. So once again, these signs cancel. Okay, and so what are we left with? Well, we're really just left with negative cosine alpha minus 1 or plus 1. Okay, that's kind of cool. So this just becomes 1 minus cosine alpha on that side. Okay. Oh, you know what? I messed up. This is a sine squared alpha. So this is a sine squared alpha. Okay, sine squared. So this really is a sine squared alpha. So this becomes, sorry, this becomes cosine alpha. That's a squared. Okay. So I didn't see the squared there. But there is a squared. So this is cosine alpha, negative cosine alpha, sine alpha, plus, and then there's this, it's a sine alpha, not a 1, sine alpha. Sine alpha, okay. Okay. And then what I could do is I could factor out that sine alpha if I really wanted to. And then this becomes negative cosine alpha plus 1. I'm trying to simplify one side and then go back and see if I can simplify the other side. Okay, and so then this 1 minus, this just becomes sine alpha times 1 minus cosine alpha, okay? Which is nice because we have a cosine alpha here, 1 minus cosine alpha here, and we have a 1 minus cosine alpha there. Okay, they just happen to be squared. Okay, if we can get this to cancel or become a sine somehow, then we're good. Okay. Okay, so let's see what we can do here. This is cotangent, okay, which is cosine alpha over sine alpha, okay, plus 1 over sine alpha. And then this becomes 1 minus cosine alpha times 1 minus cosine alpha. I'll leave it like that. Why am I breaking it up? Because I have a cosine alpha here and a 1 minus cosine alpha there. So I want to end up with a cosine 1 minus cosine alpha. Okay, one of these guys, not two of them. Okay, so I'm going to end up having to combine one of them somehow. Okay. Oops. So I'll just highlight that. Okay, so now I'm going to get a common denominator here of, this is going to be cosine alpha plus 1, cosine alpha plus 1 all over sine alpha, okay, times 1 minus cosine alpha times 1 minus cosine alpha. Okay, and what I'm going to do is I'm going to multiply these together. Okay, and this is going to be cosine alpha plus 1 times 1 minus cosine alpha. This is multiplying by the conjugates. And again, when I multiply by a conjugate, if I multiply a plus b times a minus b, what I end up doing is I end up getting the difference of two squares, which is a squared minus b squared. The middle term will drop out. Okay, so that's from algebra. Okay, and it's called the difference of two squares. Okay, so that's the difference of two squares there. Okay, and so sine alpha times 1 minus cosine alpha, this is going to become on the other side equal to 1 minus cosine squared alpha all over sine alpha. Times 1 minus cosine alpha. Okay. But what is 1 minus cosine squared alpha? Well, once again, that is sine squared, okay, from our Pythagorean identity. Okay, so from our Pythagorean identity, 1 minus cosine squared alpha is sine squared alpha. So this just becomes sine squared alpha over sine alpha times 1 minus cosine alpha. And so we get sine alpha times 1 minus cosine alpha. That equals, and then one of these signs is going to cancel. And I'm just left with sine alpha times 1 minus cosine alpha. And so since we get the right side to be equal to the left side equal to right side, that checks. And so we know our initial identity checks as well. Okay. Okay, that's 5.2. I will see you in the next section.